Hi, welcome back. In this question, we need to draw the shear force and bending moment diagrams for the given cantilever beam. This cantilever beam is loaded with a point load of 4 kN, triangular load of 3 kN per meter and an UDL of 2 kN per meter. First of all, let us label the points. Let this free end be A, this point be B, and this fixed end be C. Let us calculate the shear force at all these points. The shear force at the point A, that is at the free end, will be 4 kilonewtons. FA is equal to 4 kilonewtons. Now coming to the point B. The shear force at the point B, FB, is equal to this 4 kilonewtons plus the total load of this triangular load. The total load of triangular load will be the area of the triangle of multiply with 3 kilonewton per meter acting for a distance of 5 meters. On calculation, we obtain the shear force at the point B, FB is equal to 11.5 kilonewtons. Now coming to the point C, that is at the fixed end. Shear force at the point C, FC, is equal to this 4 kilonewton plus the total load of the triangular load, that is 1 by 2, 3 multiply with 5 plus the uniformly distributed load of 2 kilonewton per meter is acting for a distance of 3 meters. Therefore, 2 multiply with 3. On calculation, we obtain 17.5 kilonewtons. Now coming to the bending moment. Bending moment at the point A, that is at the free end, will be MA will be equal to 0. Now coming to the point B, the bending moment at the point B will be equal to 4 kilonewton multiplied with the perpendicular distance. Perpendicular distance is 5 meters. This is negative. Why? Because this is a cantilever beam and this 4 kilonewton causes a hogging moment. Then this triangular load is also acting on the beam from the point A to point B. Therefore, the total load of this triangular load will be acting at a distance of 1/3 of this 5 meters from the point B. That is somewhere else. Here it will be acting. The distance between this point and the point B will be 1/3 of 5 meters. The total load of this triangular load is 1 by 2, 3 kilonewton per meter is acting for a distance of 5 meters. This is the total load. This total load causes a hogging moment. So negative 1 by 2, 3 multiply with 5 multiply with the perpendicular distance. The perpendicular distance is 1/3 of 5 meters. Now on calculation, we find that the bending moment at the point B is equal to negative 32.5 kilonewton meter. Now coming to the point C, the bending moment at the point C, that is at the fixed support, is equal to negative 4 kilonewtons multiplied with the perpendicular distance is this 5 meters plus 3 meters. Therefore, 8 meters minus the total load of this triangular load is 1 by 2, 3 multiplied with 5 multiplied with the perpendicular distance is 1/3 of this 5 meters plus this 3 meters. Then, the moment caused by the UDL, negative 2 kilonewton per meter acting for a distance of 3 meters. This is the total load of this uniformly distributed load multiplied with the perpendicular distance is 3 divided by 2. The total load of this uniformly distributed load will be acting at the center of gravity of this loading system. That is at the midpoint of B and C. At this point, the total load of 2 multiplied with 3 will be acting. On calculation, we find that the bending moment at the point C is equal to negative 76 kilonewton meter. Now let us draw the shear force diagram. Shear force at the point A is 4 kilonewtons. Let us say this is the magnitude of a 4 kilonewton. Just let us join this. Shear force at the point B is 11.5 kilonewtons. Somewhere else here. Between the point A and B, there is a triangular load. Therefore, this will be a parabolic curve. Now coming to the point C, at point C, the shear force is 17.5 kilonewtons. Somewhere else here. Between the point B and C, there is an uniformly distributed load. Therefore, this will be a linear straight line. Join these 2 points also. This is positive quantity. I'll shade the entire area. This is the shear force diagram. We can very easily find out the magnitude of the shear force at the points A, B and C. Now coming to the bending moment diagram. Bending moment at the point A is 0. Bending moment at the point B is negative 32.5 kilonewton meter. Let us say this is the point of magnitude 32.5 kilonewton meter. Between the point A and B, there is a triangular load. Therefore, bending moment diagram for the triangular load will be a cubic curve. This is parabolic in the shear force diagram and here it is cubic. Now coming to the point C. At the point C, the magnitude of the bending moment is negative 76 kilonewton meter. It is somewhere else here. Between the point C and B, there is an uniformly distributed load. Therefore, the bending moment of the uniformly distributed load will be a parabolic curve. This is cubic and this one is parabolic. Let us join these 2 points. Let us shade the entire area. The bending moment is negative. Why? Because the moment caused by all these forces are hogging. Thank you.